Okay, hello everyone. So our today's topic is Lenz law. So we'll learn what is the meaning of Lenz law, how to apply Lenz law because that's the most important topic, how you to apply Lenz law and how to solve questions. Okay, so let's first come to Lenz law. So what is basically Lenz law? So we have already learned that whenever there is change in magnetic flux through a coil, there is an induced EMF. And suppose the coil is a closed circuit, then the current will flow. But the current can flow in two directions, clockwise or anti-clockwise. So how will we find out where will the current flow, clockwise or anti-clockwise? So this we can find out using Lenz law. So the effect of induced EMF is such as to oppose the change in flux that produces it. So what is the meaning of Lenz law? So if you try to increase magnetic flux through a coil, then the current will flow in such a way that the flux will decrease. And if you try to decrease flux through a coil, then the current will flow in such a way that the flux will increase. So induced EMF will be in such a direction that it will oppose the change in flux. So if the flux is increasing, then the induced EMF will try to decrease it. And if the flux is decreasing, then the induced EMF will try to increase it. So Lenz law is in accordance with conservation of energy principle. So this is basically a definition. We'll learn how to use Lenz law because that learning part is more important than the definition part. Okay, so let's come to the learning part. Okay, so in this figure, in this coil, suppose magnetic field is T square. So if magnetic field is T square, then flux basically depends on magnetic field and magnetic field is depending on time. So if with increase in time, B will increase, flux will increase and the flux will be in downward direction. So the flux in downward direction is increasing. So remember, if flux is increasing, then you have to put your thumb in opposite direction to the magnetic field. So if I put my thumb like this, then the current will flow in anti-clockwise direction. Okay, so if flux is increasing, current will flow in such a way that it will try to decrease the magnetic flux. So if flux is increasing, then you have to put your thumb opposite to the direction of magnetic field. Let's take one more example. Suppose the magnetic field is outwards. Suppose B is given to be suppose T cube. So flux will be directly proportional to magnetic field and it is directly proportional to time. So with increase in time, B will increase, flux will increase. But the flux now is in outward direction. So if flux increases, you have to put your thumb in opposite direction. In this case, if you see, the thumb is in opposite direction. So the current will flow in clockwise direction. So in this case, the current will flow in clockwise direction. Okay, let's take one more example. Suppose magnetic field is outwards and it is given to you that magnetic field is equal to suppose 1 upon T cube. In this case, if you'll see, the magnetic flux is directly proportional to magnetic field, but magnetic field is inversely proportional to time. So with increase in time, B will decrease, flux will decrease. So in this case, we have to support magnetic field. Since we have to support our magnetic field, so if flux decreases, you have to put your thumb in the direction of magnetic field. So in this case, the current will flow in anti-clockwise direction. So current will flow in this direction. Okay. Okay, suppose let's take this example. In this case, suppose I tell you that magnetic field is equal to 1 upon T square. Now if you'll see, the magnetic field is in downward or inward direction. So magnetic flux directly proportional to magnetic field, which is inversely proportional to time. So with increase in time, B will decrease, so flux will decrease. So we have to support our magnetic field. So in this case, the thumb will be in inward direction and the current will flow in clockwise direction. So this is the way current will flow. So what is Lenz law? Lenz law basically tells you how will your current flow, in clockwise direction or in anti-clockwise direction. Okay, this is one more question which is very tempting and also very creative question. So we have a loop here And suppose we have magnetic field B here, which is in downward direction. So magnetic field is going inside the plane. And suppose I release this loop here and the loop is moving like this. If you'll see, suppose the loop is moving towards magnetic field. Right now the current will be zero. But as soon as the loop will enter or the loop will come out, then the current will flow and again current will be equal to zero. So if the loop is moving inside magnetic field, suppose from here to here or from here to here, there is no change in magnetic flux because B is constant and area is constant. So when the loop is moving inside the magnetic field, it means the whole loop is inside the magnetic field, then the current will be zero. Similarly, when the loop was moving here, from here to here, then also current was zero because there is no change in flux. Similarly, after coming outside, the loop is moving like this, then also current is zero. But at time when the loop is going inside the magnetic field or coming outside the magnetic field, only at that point of time current will flow and the direction of current will be given by Lenz law. So suppose if a loop is moving inside magnetic field, then the magnetic field magnetic field is in inward direction. So flux will be directly proportional to magnetic field. So since B is in inward direction, flux will be in inward direction and flux will increase. So when the loop will go inside, the magnetic flux inside the plane will increase. So the current will flow in anti-clockwise direction to oppose it. So this is how you have to use Lenz law. Okay.